This problem states that a discrete time signal x of n is shown in this figure. The question reads, sketch and label the signal x of 0.5 n. So this equation itself is x of n, or this discrete time signal is represented by x of n. Therefore, the question asks, what if now we wanted to find when it is not x of n, but rather it is x of 0.5 n. So that is the question. And what we do at the very first stage is to express this discrete time signal in terms of discrete equations. And you can use whichever method you know. The only thing and one method that I use is that I observe how is xn varying with n. And here I observe that when n is 0, x of n is 0. When n is 1, this becomes 1, is 2. Yeah, so n is 1. And when n is 2, x of n is 2. And when n is 3, x of n is 3, up to that point. So for that section of the diagram, we can actually say that for the range between 0 to 3, the value of x of n can actually be said to be n. Therefore, there is another subsection where we are saying that when n is equals to 4, then n is 3. So this is the other range that we are defining. And we want to define the last range, which is when n is bigger than or equal to 5, then x of n goes to 0. And this is the range. When n is bigger than or equals to 5 goes to 0. And again, when n is less than equals to or equals to 1 minus 1, then it goes to 0. So this becomes the range and definition of this discrete time signal using discrete equations, as you can see right at that point. So that being said, so our next step is to we have expressed this, and the next step is actually to let 0.5 n to be equals to u, so that we are going to be evaluating the expression x of n minus x of 0.5 n, since our function is already x of n. So what we do is this first step, you say 0.5 n is equals to u, or u is equals to this. And therefore, our new expression will be to replace the 0.5 n with u in our equation. So the equation that we have defined here, we express it in terms of u now. So it is going to become 0. X of u, and everywhere we had n, we are supposed to replace it with 0.5 n, but since we are going to be working with u first, we are going to replace everywhere we had n with u. So we had u, u replaces n here, becomes range becomes 0 to 3, and everywhere else, as you can see, is u. So the next step will now be to replace u with now its actual value, which is 0.5 n, and but we are doing that on the right hand side. We are going to keep this thing the left hand side as it is to avoid confusion, and therefore we are going to say that where we had u, we put 0.5 n, where we had u, we put 0.5 n, and where we had u again, we put 0.5 n as well as there. So now that enables us now to work on the right hand side, leaving the left hand side untouched. And what we do next is to multiply the limits. You're now working with these limits, because this is not going to change. We are going to now to work with the limits so that the center value or the middle value remains unaffected, such that it becomes a whole value, a whole number. So we multiply both sides with the number that will cause this this n to be 1. Therefore, that factor is going to be 2. And therefore, when you multiply both sides with 2, okay, our limits with 2, this becomes 0, this becomes 6. You can say 0 to 6. And of course, when you multiply with 2, 0.5 times 2 becomes 1. Therefore, that is what we want here. So we the other limit becomes multiplied by 2, this becomes 10, and multiplied by 2, this becomes minus 2, this becomes 1. And that is the term we have there. And at the other time, we multiply by 2, it becomes 1n, and on the right hand side, we get 8. So that is how we are getting the new limits. These are now our new limits, and therefore, that now sufficient now to enable us to draw our diagram, because now we can be able to evaluate the value of x of u, or which is also the x of 0.5 n on the right hand side. And therefore this becomes, when n, now between this range, when n is 0, with this we get a 0. This is a 0, I think I forgot that. Then when n is 1, the value of this will be 0.5. So as you can see, there is 0.5. When n is equals to 2, at this point, 2 times 0.5 becomes 1. We have 2 becomes 1 here. So you can see now we are getting these values directly from this equation. And for that range between 0 and 6, the value takes the half, which is the half is 0.5 of the value of n. So this is 6. One term is not defined, and in my view, we leave it as such, because we have expanded our equation. So what we know is that we have not defined 7, we have not defined 9, and we have not defined -1, because when we expanded our range, we got double values, so we never found this out. So I would just leave it as such. What we also know is that x of n will be 3, as you can see here, or x of 0.5 n will be 3 when n was 0.5 n was 4, and therefore remains 3 when n is equals to 8, as we have done it. Therefore, this becomes 3. You can see this is 3, and so we are saying this is 3 at 8. So that defines that range. So what is remaining is now between 10 and -2. So any value bigger than 10, 11, 12, and 13, etc. They may be saying n is bigger than 10, then those values are going to be 0. And again, on the left hand side, less than 2, -2, -3, -4, etc. Those values remain as negative, as 0. And therefore, this becomes our new expression. That this is now the expression of x of 0.5 n, having derived it from x of n that we saw earlier.